We are now going to solve trig equations in degrees, and later on we will solve them in radians as well. So when you're solving in degrees, you're looking for the angle that's going to give you a specific trig value. Okay, so this is what we use to find the angle measurements, and we're always going to answer our angles within that first full rotation from 0 to 360. So if we determine that an angle is in the second quadrant, to figure out that angle measure, we're going to do 180 degrees minus x, where x is our reference angle. So let's look at an example. Find theta, so that theta falls between 0 and 360. So including 0, not including 360. That means if the angle falls on the right side, we would say that angle measure is 0 degrees. So we're given that cotangent is equal to negative root 3. So cotangent we know is adjacent over opposite. Okay, so the adjacent is root 3, the opposite is 1. That negative can go either with the root 3 or with the 1. So we know cotangent is negative in quadrant 2 and in quadrant 4. That's where our adjacent and our opposite, our x and y's, have different signs. So I'm going to sketch an angle in quadrant 1. Okay, it's going to be like one of our little bow tie angles. You're always going to draw it from the origin sitting on the x-axis or hanging from the x-axis. And then I'm going to label my sides. And I usually just label one triangle, but I'm going to label both in this case. Okay, so this will be a 30, 60, 90 triangle. Okay, so once you have your two angles, okay, and make sure you put the negatives in the correct spot. So on this bottom angle, the adjacent was the positive one, the opposite side was the negative one since it was down. Okay, so then I'm going to find my reference angle. That'll be 30 degrees. Okay, across from the 1 is always the 30 degrees. Then remember, we're measuring the angles from the positive x-axis. So this is 30 degrees short of 180. So this is where we do 180 minus x, so 180 minus 30 is going to make our first angle measure 150 degrees. Then the second one still has the same reference angle. You'll always have the same reference angle when you're solving an equation. Okay. So this one is 30 degrees short of 360. So when it's in the fourth quadrant, that's when we do 360 minus x. So our second angle measure will be 330 degrees. So both of these angles, if I go and find cotangent of each of these angles, it's going to generate a cotangent value of negative root 3. Now let's look at another example. So we have sine of theta equals root 2 over 2. Okay. This number, so sine is opposite over hypotenuse. Well, these aren't the sides of a special right triangle. Okay. Our special right triangles are 1, 1, root 2 and 1, root 3, 2. So what we need to do to this number first is unrationalize it. Okay. Anytime you're given a rationalized ratio, so that's where the number in the square root matches the number in the bottom, we're going to unrationalize it. So we're going to write it as what it was before it was rationalized. Okay. So this is going to be our opposite over hypotenuse. And now I know these are the sides of a 45, 45, 90 triangle. So sine, this is a positive ratio. Sine is positive on the top because that's where our y value is positive. And remember, opposite always goes with y. So this will be 1, this will be root 2, and that'll be 1. Same thing over here, except for our adjacent side this time will be a negative 1 since it's to the left. But both of these angles have a sine value of 1 over root 2 when you go opposite over hypotenuse. So now our reference angle, that's going to be 45 degrees. So our angle measures in the first quadrant, that's just going to be 45 degrees. When you're in quadrant 1, it's just whatever your reference angle is. In quadrant 2, we're going to subtract 180 minus our reference angle because we are 45 degrees short of 180. So that second angle measure will be 135 degrees. So now for our next example, we have cosine of theta equals -2/1. So that would be our adjacent over hypotenuse. Okay. Now if I look, this looks like it might be the sides of a special right triangle, but our adjacent is the wrong measurement. For a special right triangle, the hypotenuse needs to be 2. Okay. If I look here, if the hypotenuse is only 1 and the adjacent is only 2, it's not possible to draw a triangle with those measurements. I would draw it on the left because that's where cosine's negative. But if I try to label my triangle like this, I can see the hypotenuse is too small. So this equation has no solution because our hypotenuse is too small to create a triangle. So now for number 4, we have cosecant of theta equals -1. Okay, so cosecant is hypotenuse over opposite, the reciprocal of sine. Okay, remember our hypotenuse can never be negative, so that just means it's the opposite side that's negative. Well, now this is not the side lengths of a special right triangle. Okay, it looks like it might be a 45, 45, 90, but for that, the hypotenuse has to be √2. Okay, so if we look here, the hypotenuse is 1, so is the opposite. So if your opposite and hypotenuse have the same measurements, that means it's going to be a quadrantal angle. Okay, so this one's not no solution. It's only no solution when your hypotenuse is too small. So if they're the same, meaning they're both 1, that is going to be a quadrantal angle. So opposite, we know goes with y. That opposite side is always the vertical side. So we're looking for where y is -1. Well, that would be down here on the bottom. I can see my y value there is equal to -1. So this angle measure, that is 270 degrees. So when it's quadrantal, we don't use the x, 180 minus x, 180 plus x, etc., because it's on an axis. So remember, this is 0, 90, 180, 270. So let's look at just 2 more examples. So we have tangent of theta equals 0. So that'll be 0 over any number. It doesn't have to be 1. Okay, it can be +1, it can be -1, it can be 200. So when you have 0, the denominator can be anything. So tangent, that's opposite over adjacent. Okay, again, we don't have a special right triangle where our opposite is equal to 0. Okay. We only have a special right triangle where the smallest side is at least 1. Okay, so again, this one is going to be quadrantal. Okay. So since my adjacent side can be anything, we're looking at the opposite to figure out where this is. So the opposite side, which is y, has to be 0. So where y is 0, that's going to be both of these points on the right. So that would be 1, 0, -1, 0. So I can see in both of these ordered pairs, the y value is 0 since we haven't gone up any. So those 2 angle measures, this one is 0 degrees because we haven't rotated anything. This one would be 180 degrees. Now for this last example, again, this number has been rationalized because this number in the root matches the number in the bottom. So I'm going to unrationalize it. So then secant is the reciprocal of cosine, so this will be hypotenuse over adjacent. So this one is a special right triangle. This will be a 30, 60, 90. So secant is positive where your adjacent side is positive, which would be on the right side. So my hypotenuse is 2, my adjacent is √3, so my opposite side is going to be 1. So again, this will be a 30-degree reference angle. So in quadrant 1, that's just 30 degrees. In quadrant 2, that'll be 360 minus this 30-degree reference angle. So 360 minus 30 will give us an angle of 330 degrees.